This will be a quick run through of all your laws of exponents. We'll do a couple multi-step problems just so if you have a lot going on at one time, you know how to break it down. But here's the quick overview of the basic rules. The first one we have here, 3 to the second times 3 to the fifth, is multiplication with a common base. That 3 is the base in each term. So what we're always going to do is keep the base, and then when multiplying, you're actually going to add the exponents to get 3 to the seventh. In the next example, we have division. As in the first problem, always keep the base. I actually want to drive that point home, so I'll write one right in the next problem as well. With division, the rule is you're going to take those exponents, the 8 and the 2, and you're going to subtract them, and 8 minus 2 is 6. Oftentimes you will see a problem like this, also written as a fraction, because a fraction also means division, so keep that in mind. When you have what we call a power of 4 to another power, in this case 5, you're going to multiply those, so this final answer is 3 to the 20th. And the next one is a negative exponent, and what a negative exponent means is a reciprocal. So what we're going to do is we're going to think of this as x over 1, and we're going to flip that, use up the negative exponent, and then the 2 will still remain. So those are equivalent expressions. And the final one, x to the 0, anything to a power of 0 is 1, as long as that base is also not 0. But realistically, anything to the 0 power is 1. Now here's a little multi-step problem. It's pretty true to the order of operations. You see that these parentheses here show us that we have a term all to the negative 2. So we actually are going to do that exponent before we do any of the multiplication. And since that's a power to a power, we're going to multiply. And 3 times negative 2 gives us negative 6. Just rewriting everything else where it was. And then the next step, you've got that 4 to the second times 4 to the negative 6 in the numerator. That's like its own little quantity. So we're going to do that multiplication. And 2 plus negative 6 gives us negative 4. And that 4 to the negative 5 in the denominator is finally going to get used because this fraction means division, and our rule there is to subtract the exponents. So it'll be negative 4 take away negative 5. It's important when subtracting a negative exponent, we remember it's really like adding, because taking away a negative would be like adding a positive. So our final answer is 4 to the negative 4 plus 5, which is just 1. Last example we have here. You can see we have a quantity up in the numerator already, so we're going to start working inside that quantity. Adding those exponents will give us 2 to the negative 5. We also have that negative 5 that's outside the exponent, so we just wrote that down again. And now we're going to do the work up in the numerator first, and we have a power to a power, so we're going to multiply those. Negative 5 times negative 5 is 25, divided by that 2 to the 6th. And as always, we're going to keep the base. And since this is a division, we're actually going to subtract, and 25 take away 6 is 19. I know that was a quick run through, but if you need to re-listen to anything, just go back, pause, and hopefully all that will help you with the extra credit sheet.